All right, hello everyone, and welcome back to Calculus. In our last video, we talked about two-sided limits, or just the limit of a function as we approach an x value. This video, we are going to talk about one-sided limits. So again, when we were checking regular limits, we needed to check how the function behaved as we approached from both the right and from the left. We could also individually think about just approaching from just the right or just from the left, and these are called one-sided limits. Sometimes it'll only matter to us what happens as we approach from one side or the other. Maybe we're talking about the time coming up to an event or so forth, right? So that would be a left-sided limit because we're thinking about the time going up to a certain time value and so forth. And so also another reason to think about this is, again, a two-sided limit or a full limit. Really, it's just the combination of each of the one-sided limits. So lots of reasons to think about just one-sided limits rather than the overall limit. Okay, so formal definition. If we're thinking about coming just from the right, the way that we notate this is we think about x coming to a from the right side. So this little plus means we're going to approach x, or we're going to approach a from the right-hand side. And if that limit exists, we would write that the limit as x approaches a from the right of f of x equals c. On the other hand, if we were coming up from the left-hand side, the way we change our notation is we have this little minus sign. So we would write that the limit as x approaches a from the left of f of x is equal to c. Okay, so let's look at an example here. We saw this function last time, and we saw that the overall limit as f of x approaches, or the overall limit as x approaches 2 does not exist in this case, but each of the one-sided limits do exist. So in particular, if we think about our x values approaching 2 from the left-hand side, or from the right-hand side, what we'll end up seeing is that the y values are approaching 3. So we say that the limit as x approaches 2 from the right of f of x is equal to 3. On the other hand, if we were approaching from the left-hand side, we let x get closer and closer to 2, and we look at the corresponding points and then the corresponding y values, the y values are getting closer and closer to 2. So the limit as x approaches 2 from the left of f of x equals 2. And again, because those don't match, we see that the overall limit does not exist. Okay, so one important thing to note, again, is what I just said. Two-sided limit is just the same thing as checking both one-sided limits. In other words, this limit, the only way for it to exist, or really its definition, is that both of the right-hand side limit and the left-hand side limit exist, and they are equal to each other. So that's important. So in our last example, we had where the right-handed limit and the left-handed limit existed, but they were different. Then the overall limit won't exist. But if the right-hand limit exists, the left-hand limit exists, and they match, then the overall limit exists. Okay. So again, that is what we saw here. So left-hand limit exists, it's 2. Right-hand limit as x goes to 2 is 3. But because those two things don't match up, we get that the overall limit does not exist. Okay, so let's consider another function. So we've got, this is our function f of x. So this is another place where one-sided limits are maybe useful because we see that the domain of our function includes up to 3, but doesn't include anything after 3. So we can really only talk about approaching 3 from the left-hand side. But it's still worthwhile knowing what's going on in our function as we approach from the left-hand side. So if we look at this function and we think about our x's approaching 3 from the left, what do we get? Well, oh, sorry. So let's think about it. So we have our x values approaching 3 from the left. look at the corresponding points, and then the corresponding y values. And it looks like our y values are getting closer and closer to 4. So we would say that the limit as x approaches 3 from the left of f of x is equal to 4. Okay. We also can talk about infinite limits, and these are going to have left and right capabilities as well. So if we look at this example, looking at y equals tangent of x, if I think about approaching pi over 2 from the left, so my x value is getting closer and closer to pi over 2, but coming from the left, then we think about tracing along the graph, what's happening to our y values, they're going off to positive infinity. On the other hand, if I think about getting my x values getting closer and closer to pi over 2 from the right, and I trace along my graph, what's happening with my y values, they're going off to minus infinity. And so we have different one-sided limits for this point. So we would say that the overall limit as x approaches pi over 2 does not exist here. All right, so it's your turn now. You're gonna pause here and try a few examples. So make sure that you're paying attention to whether you're looking from the left or from the right. But go ahead and pause here and I will show you the answers in just a moment. All right, now that you've unpaused after trying this yourself, here's what you should have gotten. So the limit as x approaches 0 from the left of f of x should be 0. The limit as x approaches 0 from the right of f of x should not exist. The limit as x approaches pi over 2 from the right should be 2. And the limit as x approaches 3 pi over 2 from the left of f of x should be minus infinity. All right. And that is your second lesson.